You've got your upright tying into your gear, which ties into your unit bearing, which ties into your box, and the whole thing becomes one cohesive unit. Let's get a little transparency in this industry, and as people start jumping into the portal game, ask the right questions.
It's Eric and Quinn. We're here to talk about hubs, specifically portal hubs today. But to start it off, we figured we'd talk about what kind of hubs are on non-portal vehicles. So the classic one would be a full float hub. You've probably heard of them, floater hubs. What that's gonna be is a hub and a spindle, and it's gonna have two bearings, basically that slide onto the spindle. They'll be pressed onto the hub. What you end up with there is basically the spindle stays stationary and the hub floats around it.
And these are typically used in 3/4 ton and 1 ton applications.
Yeah.
And we get questions all the time.
We do.
Hey, can we bolt this onto a 14 bolt or a Sterling 10.5? And our answer is the same every single time, which is we cannot bolt a portal onto a spindle like this, because if we did and you drove, it would just flop around. So we have to have that 4-bolt or some type of register to register the portal in and physically bolt it to the axle. So no, we don't make portals for a 1 ton rear axle, and that's the reason why. We get that question a ton. And since we're on the topic of spindles, this is a spindle.
Yes.
That thing that your wheel connects to on the front of your vehicle is called a knuckle or an upright. I know that people commonly refer to them as spindles. It's not correct. This is a spindle. This is a hub. Hub and spindle go together.
Yeah.
The other thing is an upright. And so
just a
my rant. When people call, I broke a spindle. No, you broke an upright. You didn't break a spindle.
Yeah.
That's a spindle. Anyways.
Yeah, it's pretty common vernacular. Yeah. So for a hub and spindle, full float, the good thing about it is the weight of your vehicle is being taken by your spindle and your bearings. The whole thing is going to be hollow here. So you have a shaft running through the center, which is going to either engage a drive flange like this, or it's going to be a flanged shaft. So then your axle shaft is only responsible for torque because the hub and spindle are bearing the weight of the vehicle.
And we did a more in-depth analysis, or not even that. We did a more in-depth discussion specifically about full float versus semi-float in a different video.
Yeah, the axle housings
video. And we'll throw a link to that video, like put it in the notes or something underneath.
Link in bio. I don't
Not really. It'll be below. We'll link that video. You can reference that if you want a deeper, like really dive into semi-float versus full float design. We do it in that video.
Yeah.
But we always try to start off by defining terms a little bit, so that when we start going on a rant about stuff, that you're like, wait, what are they talking about? So Eric is good at defining things.
I'm trying. So, so then unlike the full float, then you have your semi-float axle, which is going to look kind of like one of these. These are not semi-float. We'll talk about what those are in a little bit. But the difference between full float and semi-float is semi-float will be a single bearing with...
Just keep going and I'll try to find one.
So the semi-float, you're gonna have one bearing, and your axle shaft is gonna run through that bearing, stick out past the bearing onto a flange. So your axle shaft is bearing the weight of the vehicle and transmitting torque from your differential to the wheel. So it's doing two things at once. Then you get into kind of what we're talking about here, which is something that Toyota's been doing at least since 2nd generation Tacoma. Probably before. I'm not too familiar with it before then. That would be something like this, which this is off of the new 24 Tacoma. You can see it kind of has this thick bearing pack housing right here. So what it is actually two dual tapered rollers that are they're already preloaded in there, and you just bolt this bearing pack to your housing. So whereas, full float, your spindle is stationary and your hub is spinning around it. Now, take your hub, pretend that's your axle housing, and then the spindle is going to be spinning. So that's why they call them a live spindle setup. So we're seeing that more and more. So like here's 24 Tacoma. We saw it on Ranger Raptor. You might have heard the new Jeeps have the full float axle. This is one of them. Shit. Let's see if I can get this apart. Here we go. All right, so it'll be a bearing pack and an axle shaft. This one's kind of unique because like 24 Tacoma, 2nd gen, 3rd gen Tacoma, all that Toyota stuff, Ranger Raptor, it's going to be where your shaft is actually connected to your axle flange. But then you have 2 bearings instead of 1, so it's kind of nice. But that leads us to unit bearing, because it's essentially the same thing. Someone was asking me actually on this new Jeep setup if it's 35 spline. It's not. It's 32 spline inner and outer. So bummer, but still pretty good. So like this would be the Toyota front unit bearing here. You found one?
No, we threw them all away.
We'll throw up a picture here, maybe. I don't know. That setup's basically the same as a unit bearing. So
yeah,
this would be a Tacoma front unit bearing. Yeah, dual bearing setup, live spindle. So what's good about a unit bearing? Well, it's a single replaceable unit. It's going to be cost effective because OEs make them by the thousands, tens of thousands, hundreds of thousands. And so,
hundreds.
Yeah.
Well,
So,
and the reason OEs went away from a grease pack spindle to a unit bearing design is so that with 4 bolts, you can take it off, throw it away, and replace it with a new one.
Yeah.
It's strictly for efficiency. It's not that like, I wouldn't say it's a better design. I think that grease pack spindles are typically a more robust design.
Yeah.
And the reason for that goes into bearing spread and packaging. As you widen your spread of bearings, you're increasing your ability to handle torque load on it, right?
Yeah. And your side loading of everything.
You're changing the moment, the bending moment on it. So it becomes stronger. That's cool, whatever. The problem with them is doing that in a mass production setting.
Yeah, it's a lot of parts. You have to set it up.
Well, and if you've ever done a grease pack spindle yourself, they're messy.
Yeah.
And you don't want to be on an assembly line making messy things. They have assembly lines dedicated to just this, and then they can bolt this product on.
Yeah.
And that's kind of why unit bearings evolved into the market that we have. And yeah, that's the 2 cents or the history behind it, I guess.
Yeah. Yeah, I think so. So that's kind of what's out there as far as like if you buy an OE vehicle, you know, if it's a heavy duty vehicle, you're going to have full float stuff. If it's light duty, you're going to have semi float, well, some combination.
So they're starting to move certain applications, heavy duty applications are running unit bearings now.
That's true, yeah.
On the rear.
Yeah, to this style.
You've seen them in the front end of vehicles for 20 years.
Yeah.
At least. On the rear of a Chevy 2500, you have a monster unit bearing, but you have a cup and unit bearing design now. So when people say, do you build for 1 ton? We say, no, we can't build for any 1 ton, or I guess that's a 3/4 ton application. Technically, we could build for the new Chevy 2500.
Yeah.
But we just don't right this minute.
Yeah.
But it's doable. And no, we're not going to do it.
Yeah. Yeah, don't count on that. All right, so those are, I guess, regular hubs. What kind of hubs are on portals that exist in the world? Unimogs, Hummers, things like that.
You want to talk about Hummer? I'll talk about Unimog.
Sure. So Hummer is going to be similar to something like this, where say you take these tapered rollers, you spread them out, and you put a gear in between them.
Yeah.
Basically, that's what they do. So you have 2 tapered rollers, you still have to set them up. So there's going to be a spindle nut on the back, and then you just have 2 gears that you have to set up and properly preload. And when you have case halves, that becomes a design challenge because now you need some sort of mechanism.
By challenge, you mean it's a fucking nightmare.
Yeah, yeah. So the 2 most common ways to preload, well, okay, so you can have where you have a spindle nut, where you set the preload, where you you preload it, you back it off, you tighten it up, you're trying to get, some kind of fit in there. With unit bearings, like the manufacturers have, their statistical tolerances where they can smash them together and have a certain percentage pass.
This is worth discussing, touching on. So the way a unit bearing is designed is this piece here has tapered angles into it that are ground into the physical bearing pack itself, which is induction hardened before they do the grinding. Yeah. And so you don't actually set preload on any of these. You basically just take that spindle nut, tighten it down, tighten it to 250 foot-pounds of torque.
Yeah.
And then explain statistical analysis on bearing preloads.
It's just that they tolerance it such that there's going to be a certain percentage that will fall within that range, and it's going to be very, very high.
So what he means, I guess, where you should add clarification there is that they know that these bearings need to be, you have opposing tapered rollers inside of this pack. They know that the distance apart needs to fall within a certain range.
Yes.
So they can repeatedly and with confidence grind those two surfaces in relation to each other to a specific tolerance so that when they slap bearings in it and tighten the spindle nut down, they don't ever have to tighten it, back it off, set it at a specific spot. They just ram the whole thing together and you're done.
Yeah, it's like a preset, I think is what they call it.
This is nothing new. They've been doing this for 20 years. They even, like the ones that we have in front of us, nope, not all of them. I was gonna say, the ones we have in front of us have a physical spindle nut. If you look at the end of this, what they literally do is they install the spindle through the bearing pack with bearings on it. They stick this in a fixture and they go, and they smush it together. And this piece right here mushrooms over and it's done. So this is not serviceable. If you ever needed to get into the inner bearing, you're ruining the whole thing to get there. But that's not the point. The point is they designed it as a throwaway item. So that's what it is. It's a consumable.
Well, and even with the ones with a preloaded nut on them, if you've ever taken them apart, you kind of mess it up when you pull it apart. So
they're not serviceable.
No, they're not designed to be serviceable. So with that, setting tapered rollers, Hummers have tapered rollers. In a portal where you have basically a gearbox that's clamped together, how do you set that preload for the bearings? You either need a cutout with some kind of spindle nut or some way to set that, or the other way is to shim it, which is even more of a pain in the ass.
Shimming's just not really a viable option. I did that for several years. When we first got into racing on 2-gear portals based around a Unimog 404 design, I physically shimmed each one, and it made me want to blow my brains out. It was just it's a pain in the ass.
Yeah.
And if you look at the H1 Hummer design, you'll notice that the lower A-arm hangs way the hell down on an H1, which is why it's so good for a solid axle application that like Jesse Haynes made super common. Because the H1 design, you can actually take this back cover off and you can physically tighten a spindle nut. Now, that doesn't work for us because I don't want to give that compromise up, and I don't want the lower pivot, whether it's an independent application or a solid axle, I don't want the lower pivot way down low. Our whole sales mantra is you're buying ground clearance, right? Well, if we put your lower pivot arm all the way down where it was, then you're not buying ground clearance. You're getting what you had before.
It's getting a different CV angle.
Correct. So I don't want to say the H1 design is antiquated. I'd say that the H1 design is actually pretty good for rock crawling. But if you're going to put that design on an independent vehicle, there's nothing. But it does allow you to set preload of opposing tapered rollers and do it fairly easily.
Yeah.
Cool.
Definitely. And so the one analogy for that design would be a unit bearing. The other one I want to give is a semi-float half of a housing. Because if you have a semi-float housing, so you're going to have your differential here, shaft coming through here, flange here, single tapered roller, and then you're going to have a tapered roller at the diff. And with only one bearing, it's a pinpoint. It's not a rigid, like it won't keep your axle shaft from deflecting. So that's why it's really important to have your shaft engage with the diff on a semi-float, because otherwise it's just gonna wobble around in there. So you're taking a gear and you're putting it between your two fixed points, which allows for a little bit of deflection.
That's a bad idea.
Yeah. So that's why I want to bring up that analogy, because that's also similar to a Unimog design, which
sort of. So I'm super familiar with the Unimog design. What I'll say about that is, so the Unimog design is pretty straightforward. You've got a gear, and just picture this snout on both sides. Actually, this one carries out to here. But essentially, you have a one-piece lower gear that goes bearing surface. I'll put it up here so you can see, or not. It goes bearing surface, gear, another bearing surface, snout, and then your hub slides onto that. So you've got bearings here. Now, on the Unimog stuff, they ran cylindrical roller on the back side and a monster ball bearing on the top side that was held in with a snap ring. And there's a few issues with that design. Is it doesn't do really great at hub deflection because you have a single rock point here. It is controlled on this side by this, but there were other design issues that we found on the Unimog that led us to not want to implement this design when we moved forward and designed the race stuff. And then all of our bolt-on stuff evolves from race to the bolt-on. So is this a transition point where we talk about
I guess
setup?
I want to talk about two more before we get there. Right. One would be, there are a couple, not a lot, but a couple examples out there where someone just bolts a spindle to either the box section or the backer section. Yeah. So you put, basically, you're just going boom. So now you have a gear set here independent from a hub and spindle.
Right.
So,
and that's a pretty good design.
Yeah.
If you do it right. And
so Marks and Mason, those are the two I can think of.
I'll speak a little bit about Mason. So I had a non-disclosure agreement with X-Track, who originally built the first Mason stuff. And originally what I was going to do when I started getting into before I built the first race portal, I contacted X-Track and said, hey, you guys build really good stuff. And that's what Mason was going with, because when Mason contacted me, and I said this in a video earlier, I told Mason no to our design. And I had something different in my head. What I meant is, no, I don't think my design is good enough to put in a trophy truck. Not, no, I won't sell it to you. So Mason ended up working with X-Track, and I don't know the details of their relationship at all, but I just know that X-Track was involved to a certain extent. So then I approached X-Track at King of the Hammers one year. We sat down, talked, and I said, hey, I want to build a portal around your gear set. I know you guys make good stuff. So they gave me a price and said, sure, we'll sell to you and to ID Designs. And then the ID Design stuff was kind of adopted by a couple other guys that went through, and that is essentially what ended up on that Jimco truck that Rob Mack is now racing, I believe. But that design is also a 3-bearing.
Yes.
And it's a spindle that bolts to the upright. You have a spindle carried through, you have 2 opposing tapered rollers in that, and it's a really good design. Now, the reason I didn't go that route is twofold. One, the cost for that was going to be such that I didn't think that our market in Ultra 4, not our market in bolt-on application, but I didn't think the Ultra 4 market could stomach the price point that the end product was going to need to be at, and therefore I went, I can't do this. And then at that same time, I had this idea about, well, shit, we should just build it around a unit bearing, because I was thrashing on the Unimog stuff, pissed off at how much of a pain in the ass it was, and said, I wish this was easy like the Spider Track stuff.
Yeah.
Hence, Spider Track's unit bearing.
Yeah.
So I'll step back. You can talk about the 3-bearing lower package.
3-bearing lower package.
And
so
the Mason stuff.
So I guess I don't have much more to add on the Mason stuff.
Well, so
beyond what you.
I don't know. First off, I think my NDA is up. I think maybe it is, maybe it isn't. It doesn't really matter. I'm not going to disclose any of that stuff, but I will tell you that they run 2 opposing tapered rollers with a 3rd bearing, large roller bearing.
Yeah.
And the way their hub integrates into it, it's a really good design.
Yeah.
I mean, it's badass.
Yeah.
It's just expensive.
Yeah.
But if you're racing trophy truck, you don't care.
Yeah.
So, like, again, don't quote me on this because I've never priced it. I think the Mason portals are $25,000 a corner, something like that. And they're badass.
Yeah.
They make good stuff.
Yeah.
But we didn't go that route because I just didn't see it as a viable option.
Yeah. So and then there's one other 3-bearing design out there.
And there is one other 3-bearing design.
So other than ours, which if you do
other, you're talking about ours.
Oh no, so there's other bolt-on portals on the market where it's it's bearing gear, dual bearing pack.
Yeah.
So
you mean a dual row ball bearing?
Yes. Well, there's dual row ball bearing or angular contact or like these ones.
Sure.
Yeah.
Okay.
So it's basically the same as just having a bearing on both sides, but one is a preset dual bearing pack.
Sure.
And the con with that is that it's wide.
Yeah. It's going to be very wide because those dual row bearings are like that wide, and then your hub has to register against that to add the load or to add. It's not preload to the bearing pack because all you're doing is pinching that inner race.
Yeah.
But what you're doing is that's how you're constraining that bearing in that application.
Yeah, and keeping your wheel constrained laterally.
And that's wide.
Yeah.
Yeah, there's just no getting around that.
Yeah.
Then we get to our design.
Which this one's probably the best one to.
So easiest one to, well, we'll do the race stuff first. So what we have here is a Spider Track's Pro Series bearing. So this is a 56 spline, like 2 3/8 diameter broached hole here. So inside of this bearing pack, you have 2 massive opposing tapered rollers. And this bearing pack, the reason we started with the Spider Track stuff is because Spider Track uses specific alloys for their wheel flange and the physical spindle itself. And they're a good company. They make really good quality stuff. And why not just use something if it's there? Because we didn't want to make it. And they have a great reputation. So we have 2 opposing tapered rollers in here that were originally designed for the F650. So they're big and beefy. But the reason they use this bearing pack is because now they can fit a monster spline through the thing. And what we do is we take our gear, and this mate's in there somehow.
It's tight.
It's tight. And that index is in, and then the way we preload the bearing pack is with a spindle nut on the outside here, And like I mentioned before, these packs are all ground, so you're not tightening it and then backing it off and feeling it. You're putting 300 pound-feet of torque on the end of this, and the Spider Track stuff has a way to key and pin in place so it can never come loose, and you're done. And then where our design differs from everyone else on the market is we then hollow out our gear and we run a needle bearing inside of this, and that needle bearing is good for an additional 30,000 pounds, I believe. Yeah. And so what happens is you have an upright here, not a spindle. The spindle's in here. You have an upright which has a male spud that comes off of it, and that male spud has a bearing race on it. That bearing race registers the gear, which then registers into the unit bearing. The unit bearing bolts to the box, and your wheel bolts on to the face. So you have 3 bearings. You have 1, 2, 3. But the important part is you've got your upright tying into your gear, which ties into your unit bearing, which ties into your box, and the whole thing becomes one cohesive unit.
Yeah.
And suddenly it becomes really strong. And now I'm not even gonna touch on the Instagram post.
Oh, okay.
Where we got,
yeah.
Somebody took a shot at us, and then I took a shot back, and then they took the post down. Whatever.
He likes to get after it on Instagram in the comments. So.
Hey, man, like, I'm opinionated.
Yeah.
So, our 3-bearing lower design has, it's one thing for me to sit here and go, oh, it's a good design. It's another thing for us to go, yeah, we've been racing on this for years. We've got hundreds of applications that are running bolt-on stuff for years. It works. Yeah. And it really does. And if you look at the load rating of this whole setup, it so far exceeds every other bearing configuration that, like, it's total overkill, but that's kind of what you want when you're going to go to a big tire and potentially thrash on the thing. Because if the unit bearing ever rocked in that box, yeah, you'd break the box for sure, and then your whole wheel would fall off and shit would go really wrong really fast.
Really fast, yeah.
Kind of like snapping an upright.
Mm-hmm.
Yeah, so that's not going to happen because, again, wheels tied into the unit bearing, which is tied into the box, which is tied into the gear, which is then tied into your upright.
Yeah.
And that design is essentially the same as what we do for our bolt-on. Now, we make it to where it's a very slight press, so the gear physically becomes part of the spindle. And this is why also that we don't offer locking hubs.
Yeah, because we tried that.
We did try it, and we never had a failure with it.
No, we went 10,000 miles on that design.
We did, but we also saw a little bit of tooth wear.
Yeah, uneven tooth
uneven wear. And we went, oh, the gear is not actually being stabilized as good as we would like.
Yeah.
And so we changed that design before we released anything. This is why you test.
Yeah.
Don't test with your customers. We test with ourselves first.
Yeah.
There's a fucking novel concept. Anyways, and so our gear on our bolt-on stuff presses into the spindle. And so if you were to run a locking hub, what essentially you would be doing is having these 2 items spin independent of each other. And our gear is case hardened to a specific Rockwell hardness. Not going to tell you what that is. And this spindle here, so this flange has a spindle that runs through, that is induction hardened to a different hardness.
Yeah.
And if you have metal on metal, even if there is lubrication there, it's not the best idea. You could, in theory, put like a DU bearing or an oil impregnated bronze bearing and then have them spin independent of each other.
becomes a wear item.
It becomes a wear item, and we basically, actually, the real reason why I said fuck it to locking hubs was I was having a conversation with Ben Faulkner, who is the president of Terraflex. And Ben tells me that we were talking about locking hubs versus just broaching this, which is easier.
Yeah.
And Ben said, you know, we did a study where we drove a Jeep on a closed course with a 40-inch tire with and without a locking hub and measured the fuel economy gain from the locking hub in a as controlled of environment as we could. And he said the end result was 1%.
Yeah.
And I went, cool, well, you're gonna go to a 40-inch tire, or even if you're not going to a 40, you're going to a big tire. You made the decision to go with a big tire, live with it, dude.
Yeah.
You're not gonna get great fuel economy. So the amount of gain that you were gonna get was just not worth it.
Yeah.
And then it allowed us, by having this a slight press into the spindle, it allows us to make a much stronger package. So again, same concept, smaller package.
Yeah.
You've got needle bearing that ties into spindle, that ties into box, or upright ties into gear, ties into unit bearing, ties into box, and then your wheel mounts on it.
Yeah.
So you just gain a lot of strength, and the most important thing is that your portal box itself, so the part that this unit bearing bolts to, is not under that bending moment because it's combated by a spud on this side. And this is where we dive into materials. That spud is a 70-75 aluminum. It's really frickin' strong.
Yeah. So, I mean, that's a big part of gear strength, is mitigating gear deflection.
Yeah, and that is a function of your bearing package.
Yeah.
So I think I've said it in a video before, but to me, the hardest part of designing a good portal is not the gear set, it's the bearing package.
Yeah, the bearing, because the loads, when you chart it out, are pretty astronomical.
Yeah. And they're also unrealistic.
Yeah.
It's really hard to...
It's hard to do pen and paper.
It's hard to do pen and paper.
Yeah.
We get it. We know how to do the math behind it, but when the math tells you one thing and you're like, okay, what are we missing? It's very hard to just sit down with a piece of pen and paper, even if you know the equations. You can come up with numbers, but then you look at it and you go, are those realistic numbers? Because it's not like this is an isolated part. It's hooked to the entire drivetrain. So you have concepts like parasitic loss and the torque converter and engine management software on new vehicles that defuel as like, this thing bugs the shit out of me that I can't sit there on a new vehicle and I can't mash the brake and the gas at the same time because it'll defuel the car.
Yeah, it only lets you get so high on the RPMs, right?
Don't you know that I like to party?
Yeah.
Like, really? You can't do a power brake and burn through it on a modern vehicle? That's all engine management software that plays a part of what is the actual number and how much torque are you really putting down to a product at the wheel. Sorry, rant, done.
I guess it's worth touching on. This is our unit bearing right here. So people ask us, what is it? Is that a 99 to 04 all the time?
Sure.
It's essentially the same bearing pack, same strength as one of those. But if you think about, well, I don't know how much you want to say.
What?
About our bearing pack. So we have it manufactured with a tone ring in it.
I'm willing to talk about a lot of this stuff because I filed a bunch of patents around it, and so I don't really care. And let's be clear, all a patent is you file it so that now you give the public full access to your design, and in exchange for that you get an exclusivity thing. And just because you have a patent on something, it really comes down to the defense of that patent. Not so much the patent itself. But This is well, yeah, we'll talk about it, sure.
Okay.
It's a bearing pack that we have made for us. These come out of Ohio.
Yeah.
It's a 99 to 04 Ford F350 Super Duty.
Which, same as that 550
So,
for the front end.
but that's about where it stops.
Yeah,
so
it's the same bearing set.
bearing set. There you
Yeah.
go. So if you physically measured the OD and ID of that tapered roller bearing that's inside of this, it would match it.
And it'll bolt to the knuckle, but that's it. You can't install a shaft. You can't do anything else.
And the reason we can't take an off-the-shelf bearing pack and use it in our application is because you're going to want ABS.
Yeah.
So your ABS wheel speed sensor bolts into this spot here. Now, if you look at the angle, or if you look at the mounting surface of that on this, we'll put them side by side, sort of, angled so that the camera can see.
Yeah.
99 to 04 is cut at an angle because the sensor protrudes in there and reads a tone ring at an angle.
Yeah.
But the Jeep one is perpendicular
Yeah.
to this surface. So you can't take this and like modify it and re-drill it and then put a Jeep wheel speed sensor in there. It won't work. So this is essentially a custom bearing pack that we have to have made for us. And so 99 to 04, Jeep wheel speed sensor, Jeep tone ring inside of this, 8 on 6.5, because this is 8 on 170, 8 on 6.5 bolt pattern, and then we don't give you the option to run a drive flange or a locking hub.
Yeah, it's just broached through.
We just broach the inside of it out to 1.5" 35 spline standard.
So then we have a little stub going from
and then
here
we
to
have a
there.
tiny stub that connects the two. So yes, we keep hundreds of them in stock.
We do, yeah. We have a whole sea container full of these things.
Yeah, we have a lot of them.
Yeah. So, and a lot of people ask, why didn't you do the 05 Plus as your baseline platform for the bolt-on stuff? And
valid question, because it's better.
Yeah, it is better. It's going to be stronger. It's a narrower package. But the problem is, for every portal we make, to try and keep it as simple of an install as possible, you need a window to be able to retain either your front CV shaft, stub shaft, or your full float shaft on the rear axle. With the 05 and our gear spread, we didn't physically have space for a window.
Yeah.
So that means that we would have to make custom axle shafts.
It just didn't fit.
Yeah.
It didn't fit. And with regards to 99 to 04 Super Duty bearing packs, hey, how do you know they're strong enough? I don't know, because Ultra 4 raced on them for 10 years. Well, I shouldn't even say Ultra 4. There was a group of us that would go out and wheel hammers before Ultra 4 was ever Ultra 4, and we always ran on those. And I've had extensive conversations with the guys from Spider Tracks. They started out by modifying 99 to 04 Super Duty bearing packs before they made their own. And if you look at like half the field at King of the Hammers, they're still on 99 to 04 Spider Tracks bearing packs.
Yeah.
Now, Spider Tracks uses a different alloy, a different heat treat process. The Spider Tracks Ultimate Series unit bearings is a better quality bearing pack than ours.
Yeah.
And it's $1,000. It's worth it, but we can't buy those. People already complain that $5,000 is too much for an entire portal.
Yeah.
If we're spending $1,000 for a chunk of aluminum for your upright and $1,000 on a bearing pack, and then we still have to machine everything and build everything, it just becomes cost prohibitive.
Yeah.
So we run that Spider Tracks unit bearing on every one of our 2-gear portals. We make our own for 99 to 0, or for all of our bolt-on applications. It's just a cost thing, and You think we're expensive now. If we went with that bearing pack, we'd be more expensive. We'd be
Yeah.
4,000. We'd be slightly less than $4,000 more on our price than we currently are right now.
Yeah.
So, and let me be clear, I ran a early edition of a SpiderTrax Ultimate bearing, which was essentially same materials as we're using here on a buggy that I had for 10 years that I wheeled the shit out of on 40s and then 42s, and I never had a unit bearing fail.
Yeah.
And what we used to do on the old SpiderTrax stuff is we would stitch weld the back of these to keep the spindle nut. Now we just have a procedure with a special type of primer and then red Loctite, and we don't see those come loose, but it's a proven bearing with a history in Ultra 4 before it was Ultra 4.
Yeah, and big dog crate axles.
Yeah.
So,
well, and okay, like every win that Jason Scherer has ever had at King of the Hammers, all 3 of them have been on 99 to 04 Super Duty bearings, and he was 5 lug on those too.
Yeah.
I'll do a rant on 8 lug versus 5 lug some other day. I don't like.
Yeah.
I don't like 8 lug. Yeah. I like 6 lug. But whatever.
I mean, less lugs. I mean, well, just kind of funny. So, conventional wisdom is you can't have a 5-on-5 full float. Found one on eBay. Super Speedway NASCAR hubs.
That's 5-on-5?
It's 5-on-5, 5/8 studs. So I found them on eBay because they went to center spindle nut like F1. And so before I came here, I found these on eBay, and I was going to make a rinky-dink axle. Yeah, now they're just sitting there.
How much did you pay for that?
Like $80 for the set.
Shout out to eBay.
Yeah, shout out eBay, shout out Super Speedway Engineering.
So here's a comment that I'll say. I don't know how wide the werewolf or the tibus stuff is, and neither do you. So I will give you exact numbers.
Yeah.
I will tell you, and I'll put my money where my mouth is. I'll back this up. Where on Jeep we add 3.75 inches per side. On Bronco we add 3.5.
Yeah, it's a little less.
A little less than 3.5 inches a side. On the new Tacoma platform, we balance out at 2.75 inches of width added per side. I have seen all kinds of numbers thrown out there of how they're the same width as ours, wider than ours, narrower than ours. I've seen everything across the board. What you don't see is accurate numbers on their website, or them willing, or anybody selling their stuff willing to actually give you the number. And like, okay, if you take stock vehicle is this wheel mounting surface, then you put a portal on it, it's this wheel mounting surface. Like, those are critical things that as a buyer, I would want to know. Let's get like actual information on that. And I've dug a little bit and I can't find it. So if you have one of those products and you're willing to throw that in the comments below, I'll put our numbers in there and let's actually do a comparison, because I'm confident that when I say that we are hands down the narrowest portal on the market, guaranteed, because anytime you're trying to take a portal and make it universal and then bolt it to the knuckle, you're losing out and you're gaining width, because how do we do it? We build a whole new knuckle, sink the bearings into the knuckle, push everything as far back as we possibly can, starting with a blank canvas, and then you get the best package.
Yeah.
So if you're cool with being, 95 inches wide, okay, that's personal preference there.
Yeah.
I'm not.
I mean, for reference, like if you take JK, that's a 65.5 inch wide axle, wheel mount to wheel mount. If you look at like a Dynatrac crate axle, they come into with 68.5, 72.5. We're gonna bring you, with all the work we've done to keep it as narrow as possible, to 73.25. And so you're already getting more wheel mount to wheel mount than a full width Dynatrac.
Yeah.
But then you can run deep backspace wheels.
But then
pull your tires back in.
Exactly. We go, hey, run a plus 25, 17 by 9. We list the wheel out on our website, and your vehicle on portals would then be narrower
Yes.
than a traditional Jeep on a 72.5 wide Dynatrack, because you're typically going to pair that most of the time with a 0 offset wheel.
Yeah.
Our wheels are 1 inch per side narrower, so while we're a little bit wider on wheel mounting surface by, say, an inch,
Yeah.
we're 2 inches narrower overall via the wheel package, so we actually come in narrower than the big Dynatrack package. Yeah. Maybe some of you don't care about width.
Some people like them wide. Wide boy stuff.
Yeah, that's fine, but my point with all this is let's get a little transparency in this industry, and as people start, jumping into the portal game, ask the right questions. Hey, how much width does it add? And if they tell you 3.75 inches per side, let them know that Quinn says that you're a liar. Sorry.
No.
I heard laughing from under the Ranger Raptor.
We have Dylan, he's down there 3D scanning for some
yeah.
stuff. And
I joke about all this stuff, but I joke, but I'm not actually joking, because it does piss me off when I know that other companies are saying stuff that I haven't put my hand on their product, but I'm pretty confident that if I did, I'd find out that they were full of shit.
Yeah.
Sorry. We only add 3.5 inches to the Bronco. No, you don't, bro. Your vehicle is 101 inches wide. You do that all in wheels? I don't think so. So
yeah.
I would love if somebody was running some of that other stuff to throw wheel mounting surface numbers. And this is why, when I do a video out there, I'll pull a tape measure on that and I'll physically measure it there. I'm not going to stand in front of a vehicle and go, I just measured it before we shot the video and it's 80 inches. And you're like, show us the measurement. I'm all for showing you the measurement.
Yeah.
And
if we get a customer calling us saying my enclosed trailer is this wide.
Prime example. Hey, will I fit inside of my enclosed trailer? And they go, yeah, you're only going to be 89 inches wide, and your trailer opening is 90, and then you suddenly bolt that thing on and you're 92.
Yeah.
Now you can't fit into a trailer.
Yeah. Not ideal.
Okay, I'm done.
So,
sorry.
I guess the other thing that I think is super cool about our unit bearings is that we have another one that we're having made for us, a 6 on 5.5. And that's going to be very cool, because something with Toyotas that has been a problem is they use this magnetic encoder back here, which isn't like a mechanical tone ring where you can physically make a part to, you physically machine a part to mimic a tone ring.
Yeah, keep going.
Okay. Well,
sorry.
I think it's very cool because we're going to have a 1-ton unit bearing compatible with magnetic ABS.
Well, we already
have it.
Through the 120 that we had, as fast as we could get them. We built them and we shipped them out.
We're going to make volume of a magnetic.
We have actual volume coming, which is bitching.
Yeah.
So
very exciting.
I'll speak briefly on magnetic encoders. How do you know if your vehicle has a tone ring or a magnetic encoder? Do you have something called hill hold? So if you get on a hill, does your vehicle roll backwards, or does magically your vehicle hold and it doesn't roll backwards? So the way vehicle software manages this is they have a magnetic encoder, they call it, where they have oriented pairs of magnets, and they're oriented north-south, and they have a certain amount of pairs of magnets that run around this black ring out here. And so your wheel speed sensor picks up a signal, and the easy way to think of it is because of the magnetic field that comes off of those and how they're oriented north-south, they can tell whether it's going forwards or backwards. And so as the vehicle starts to roll backwards, it can then trigger a sensor inside of, I don't know if it's the transmission or what, and hold the vehicle there and prevent it from rolling back. So if you have hill hold, then you have a magnetic encoder. And Toyota's been doing this since 2003.
Yeah, they've been doing it a while.
Jeep is still on.
Jeep's still mechanical.
Jeep's
Shout
still
out Jeep.
Mechanical. Shout out, dude.
And Ford for Super Duty stuff is still mechanical, so that's nice. In the front at least, but not
Raptor.
Bronco.
Nope, but Bronco Raptor is still magnetic.
Yeah.
Or sorry, is still mechanical.
Yeah.
F-150 is still mechanical. But the writing is on the wall. Everything is going to go to magnetic encoders. So being able to parse a magnetic encoder is kind of hard.
Yeah.
But we figured it out. If you technically can, I believe, run a tone ring in place of a magnetic encoder, because that is what tibus does on the upper gear. But in the process of doing that, you lose that hill hold functionality. So if you go that route, that's fine. You just don't get hill hold anymore. And maybe you don't care about that. And I'll be honest, like, I'm not going to sit here and be like, I don't want to lose. I don't care about hill hold. I put my foot on the brake. Yeah. Like, if you could eliminate the entire ABS system for me, I'd be stoked. Like, don't tell me when to brake. I want to be able to lock those things up, man. I don't want them pulsing.
Yeah, as long as it doesn't make it so it can't pass smog in California, then I'm happy with it.
Yeah. So our ABS compatibility is with a factory magnetic encoder using the factory wheel speed sensor at the wheel of the tire. So it's reading actual tire speed, not inside of the gear reduction.
Yeah, you don't have to cheat your tire size and all that. Because I've had a pretty bad experience on JK with the 5-speed trying to cheat tire size.
Yeah.
It's not good. It doesn't like that.
The vehicle locked up at, how fast were you going?
I was on the freeway. There was a little bit of traffic, so it was 55. And I had a little bit of a gear ratio mismatch. So it's like, on paper, I got everything right, but it knew. and it granny shifted me enough to screech the tires.
So it downshifted enough to break the tires loose. Yeah. And it was angry.
Yeah, not happy. So,
okay.
Yeah, the new vehicles are smart, so we're trying to keep it as factory as possible.
No, they're not smart. Sure.
They're integrated.
They're complicated. They're integrated. That's the biggest headache.
Yeah.
But whatever. It's not, though, in the sense that we just sit back and kind of laugh, because when other people try and do this, we go, oh, wait till they find out the headaches they're about to get into. And there's ways to cheat this stuff, but we try not to cheat anything because you don't know what you don't know until you cross that bridge. And if you cheat something like Eric did, and it worked fine, and then a week later he's driving down the road and his fucking transmission locks up at 55 miles an hour, and the tires come screeching, and he thought that he like blew the whole transmission.
Well, I'm on prototype portals, and all of a sudden it's hurt. So on a closed course in Mexico.
On a closed course in Mexico. So sometimes there are unintended consequences, and that's why we like to give you guys a little bit of insight into this kind of stuff, how we do testing, show you the insides of our guts, basically lift up our skirt and say, check it out. Transparency is a good thing in an industry that I think most industries don't have much transparency, right? And so the way I kind of look at these types of videos is, if I was a consumer, what would I want to know? And then we go, okay, then that's our responsibility as a manufacturer to give these kind of insights. And so we sit down and talk to a core group of you guys that like the tech videos and throw this shit out there, and you let us know what you think. And if there's other, I say this on a lot of the tech videos, if there's other topics that you want to know about, throw it in the comments. But we have an ever running list of this stuff, and like,
Yeah, we have too many to do.
Dude, there's no shortage of, hey, what about this? What about that? Yeah. So no shortage of these topics.
If you're still here, shout out to you.
Cool, and we'll catch you on the next one.